Oh dear, what a mess. Welcome back to my channel. I've actually had a bit of a clear up now, so I've got some space to show you some stuff on my bench. Concluding basically from the L12 projects on the previous 4 videos, I've been asked by a number of viewers if I will show how to actually incorporate this board or any other amplifier board into a sort of working project. Now I need to clarify when I said any other amplifier, because that's not strictly true. What I'm talking about is virtually any amplifier that operates in class A, B, which indeed the L12 and many modern amplifiers do. The reason why I specify that when I'm talking about a supply is fairly simple really. These type of amplifiers by and large need a split rail. In other words, the reference point is, if you like, the ground, and it needs a positive voltage of, in this case, up to 50 volts, and also a negative voltage below the 0 volts. So if you've got a class AB, this is some of the ingredients you will need to make it work properly. Let's have a look first of all at the transformer. These days most people would probably purchase a toroidal transformer because of their size, cost and general availability. This particular transformer originated from China, as indeed most of them will. When I purchased this transformer, probably about 7 or 8 years ago, it was for the purpose of building my first L12. And in fact, this has been inside an L12. One of the things that you need to consider is the input voltage on the primary. Most transformers that originate or that are supplied, I won't say originate because most transformers these days tend to be made in China, but if you purchase them from the likes of Mauser or Farnell or RS Components, to name but 3, most of these will have the working primary voltage of your country. Now in the case of New Zealand, whether you can see this or not, let's lift it up a little bit. This says 220 volts. Now that is because if you buy these from China directly, that is what they would call a universal voltage, and what it really means is it isn't suitable for any country. Here in New Zealand we typically have 240 volts as the nominal voltage, as indeed I believe so does Australia and certainly the UK. This transformer you can use with a 220 volt primary. The effect of that is, and the only real effect is, that the secondary voltages will be appropriately higher, which may be to your advantage if that's what you want, but it could be detrimental if you don't want it. This one, it says 36-036. With this transformer connected to the power supply in New Zealand, that will actually produce about 37 to 38 volts off load, which is a little on the higher side and will generate roughly about 52 to 53 volts DC when appropriately filtered and rectified. Now the L12 in particular does specify up to 55 volts. In my humble opinion, pushing it, I would not generally recommend you use more than 50. But as this is a general video, It may be that the module that you've chosen to use is very happy with 50, 55, or maybe even 60 volts, whereas such a transformer will be absolutely perfect. The other advantage of this particular transformer is it does have two other secondary voltages of 12-0-12 and a 6-volt supply, which is less than useful, but I don't know, maybe on your project it would be fine. The 12-0-12 is obviously perfect for running a preamp or something like that, but ironically such transformers are comparatively rare. So you may have to use another small transformer. I mean, the way that many manufacturers do this is to rather than put a separate transformer in, they will use a voltage regulator. But getting down to 12 or 15 volts from 50 is quite a voltage drop, and they inherently run really hot. And they are the downfall of many domestic well-known brands of amplifier, that they use a linear regulator to drop the voltage. But they have to do that because of space limitations generally. But given the choice, I would not do that. I'd forget about, if you can't get a transformer that has a secondary voltage of 12-0-12 or 15-0-15, use a little tiny transformer. They're dirt cheap and they work just as well. This is a sneak preview of the amplifier project that I'm putting together, and you can see the transformer here. Look at the size of my hand. This is a big transformer. I'm using it A, because I've got it, and B, what's the other reason? It happened. I knew there was a reason. It happens to have the right voltage for this particular project. I mean, you can see from the various windings here that it does have rather a lot. Well, it has 3 separate secondary windings, but the one I'm using, which is just out of sight on the red and black wires, just happens to produce just the right voltage for the current L12, and the secondary on that is 35.3 volts, twice obviously, which gives you an AC rating of 70 volts. Now, once it's gone through the rectifier and smoothing block, we'll talk about that presently, that will give you 48.4 volts off load, which is as near perfect as I would suggest. This particular transformer is overkill, I would point out straight away. You can see that by the size of it. But this originally came from a Yamaha AV amplifier of somewhat vintage, and it was driving 3 channels at 100 watts into 8 ohms each, and it also had 2 30-watt amplifiers on a separate winding. Those will be largely unused, but they were used for the surround channels in this early AV amplifier. A transformer like that today would, I doubt you'd even be able to buy one, but it would certainly cost you a great deal of money. But I'm using it because I've got it and it's already screwed to the chassis. Let's have a quick chat now about power ratings. As you can see, we're back to the toroid, and this particular one has a rating of 300 AV. And it was perfect for driving 2 L12 modules. You could argue, and I'm sure you're already almost poised to put pen to paper and say, a 300 watt transformer for 2 amplifiers that are capable of producing 200 watts each into 4 ohms is going to overrun the transformer. You'd be perfectly correct in making that assumption. But what you have to consider is that is if you're driving it sine wave into 4 ohms, both channels driven. You'd need a transformer theoretically of close to double that. Because music after all is not a sine wave or a square wave. It's probably nearer a square wave. Peaks may well extend 50, 60 or maybe even 100 watts, but they're there for milliseconds. So the power supply has a lot of current and voltage stored in it. Realistically, a 300 watt toroid, and even then, when you look at some of the commercial amplifiers available of quite well-known names, they will often have a transformer half that. And I wouldn't recommend half that, to be honest, unless you're going to be listening at low level or moderate level all the time. This is the next item you will require. It's basically rectifiers and smoothing capacitors. These are the rectifier diodes, and there are 2 diodes in each package, as you can see there. In fact, there's 3 wires. It looks like a transistor, but they are in fact Schottky diodes. I would recommend that you use a power supply with these because they inherently have a low voltage drop. Because if the voltage drop is lower, you're going to produce less heat, which is good. But one thing I would suggest is make sure you buy one with heat sinks on them. Because some of the cheaper ones, they just have the same basic diode, which is good, but they don't put a heat sink on it. And if you imagine what you're going to be drawing in current from these things, the heat sink is very important. And in fact, if you're going to drive it hard into 4 ohms, I would suggest you use 2 of these power supplies. The next thing that's important, obviously, I guess, is the smoothing capacitors. These are made by Elner, but the main thing you need to look at is the rating. These are 10,000 microfarads, but the working voltage, as you can see, is 63 volts. Dare I say, in the old days, capacitors used to have 2 ratings. One of them was the peak voltage, and the other one was a maximum working voltage. They were rated like that mainly because in the black and white days that I'm talking about, there were things called valves. Valve rectifiers in particular used to heat up before the main valves in the amplifier because they were directly heated. The effect of that was they would start producing high voltage DC within 3 or 4 seconds of switching on. The downside of that was the main valves, which were indirectly heated, would not. You would have a huge voltage appearing across these capacitors, and that was known as the surge voltage. It could be considerably more than the voltage that the actual capacitors rated at. So the capacitors were designed to, let's take an arbitrary number of say 300 volts, but that would be the working voltage of the amplifier. For safety, I would suggest that you'd use probably 350 volts. But when you first turn the amplifier on, the surge voltage could well go to 400 or maybe even more, depending on the circuitry, which clearly would distress a 300 volt capacitor. But they were designed to handle this surge voltage. For example, these are rated at 63 volts. I wouldn't put more than 55 volts maximum on those capacitors. Other things this board has, it has the obligatory LED, which are amazingly bright and ridiculously so, but there you go. That's the series resistor for the LED, so you can always change that resistor if you don't like the 2 kilowatts of light coming from these LEDs. Here is your inputs. This resistor here, and the same one the other side, is a bleed resistor, and all that does, it's across the supply, so if you turn the power supply off and there's no load on it, these will slowly discharge the capacitors, but they do stay charged as a warning for probably 20 or so minutes. So don't get your screwdrivers anywhere near these capacitors, because you will just blow the screwdriver to pieces. Here is also a small cap, which again is just across the main capacitors, which is a done thing these days. Now, I did mention earlier that you could use 2 of these, and I hear you ask, why would you want to do that? The answer is simple. As the load increases, the voltage will drop, because this is not a stabilized supply. In the past, I've built L12s and other amplifiers with this single board, and it performs superbly. But if you're going to drive it continuously at high power, if you use 2 of these and you literally have the transformer going into here and in parallel with the second module, the output from here, your DC, you just feed one of these to each amplifier. Obviously you will get less current drain on the single module, so less voltage drop, so you will actually obtain higher powers for longer, more sustained basically. But that's a luxury if you've got the space to put them on, because they're not expensive, these modules. Nice thick traces. This is not a kit, by the way. I don't know whether you can actually buy it as a kit. What this is, in fact, is a surge limiter. And again, not an expensive module. And you can see from this, there are just 4 terminals on it, and it's 2 in and 2 out. The purpose of this module is to limit the switch on surge that you can possibly get or will get when you first turn on the amplifier. It's caused primarily by 2 things. The first one is that with whatever kind of transformer you use, the bigger it is, when you first turn it on, its DC resistance, if you put a test meter across it, could be as low as 5 or 6 ohms. And it's only when the current starts to flow that it changes from inductance, or I should say changes from resistance to inductance. Now clearly if it didn't do that, you'd be passing many amps. Well, simple Ohm's law, work it out. You could be passing hundreds of amps. But the moment the transformer magnetizes, you then see the complete inductive load, and this is all happening in milliseconds, so it's not sort of 5 minutes or something like that. But it means initially the current flows through that transformer into almost a short circuit, and it can draw considerable amount of current, and it can even take circuit breakers and fuses out. So that's one of the reasons why you'd use such a module. The other thing, of course, it's doing, the moment the transformer is transforming, for want of a better word, the first things it sees is your diodes, huge capacitors, which again, it almost looks like a short circuit because they will need to be charged. This all happens initially at really astonishingly fast speeds. Is that even English? When you first apply power, there's the surge of the transformer itself, and it doesn't matter if it's a toroid or a conventional transformer, they all, well, suffer's not really the word, it's just the way they work. You've got that to deal with, and also the charging of the capacitors. You can virtually ignore the amplifier load because initially there won't be any huge current draw from the amplifiers because they'll be under quiescent conditions. Well, I suppose unless you started off with the volume pretty well on full, in which case the current draw can be even more, but not a good idea. Always start with the volume near or off. Will you need one of these modules? It depends on many things, and there is not really one rule, because I've used amplifiers of such power without them before, but we're advantaged here by having 240 volts. Now obviously if you're in a country that uses 110, 120 or even less, the current will be more or less double because the voltage is lower. Not strictly accurate, but you get the meaning. So the current flowing when you first turn on such a system with 120 volts going in would be considerable, and you either end up having to take a larger fuse, which again is counterproductive because the fuse is there to protect against something drawing lots of amps. If you use one of these little modules, I know I'm pointing over there because that's where it is. All these little modules is a circuit that puts a resistor or some other component in circuit for just a second or so, and it just enough to limit the current going in, so it won't make your lights flicker. I'm sure you've, particularly if you're in countries with 120 volts, you put something like that on and the lights just flicker, don't they? That will prevent that, and it then operates a relay after 1, 2 or 3 seconds, whatever your particular module is designed for, and just takes away that surge. And it also has the advantage that it won't damage the fuses prematurely, and possibly something you haven't thought about, it won't damage the on-off switch. Because when you think that what a switch is, you're making contacts like that, and the current going through those on that first surge is horrendous, way outside the rating of the switch. And you'll find on vintage amplifiers and things, often the mains power switch has failed, and it's purely sparking, basically arcing for even a better word. One of these modules is ideal, and it's as simple as this. The power comes in to this module and goes out to your transformer with a switch somewhere in circuit, and that's what I've got wired up here. This is probably the most important module of the lot. This is a speaker protection board. If you don't use one of these, you are driving a very dangerous route. Anything goes wrong with your amplifier, and even the best one at any price can go wrong in some way or another. And don't forget, the L12, just as an example, has nearly 100 volts across it. If something goes wrong and that 100 volts or even half of the voltage appears across your output terminals and into your speaker, you have written off your bass units. Ironically, it probably won't affect the mid-range or the tweeter because they have capacitors in series with those particular drive units. But the bass unit will not have capacitors in series. That's why DC offset, which this board also protects against. This IC is part of the speaker protection, and it also provides the delay required to check that everything's okay. So when you switch on, this normally clicks on after about between 5 and 10 seconds. What it does, apart from providing the delay, it also checks the output and to see that there are no nasty voltages present. And if there are nasty voltages, all these voltages appear when you're using the product, it will stop these relays clicking in, saving your loudspeakers, and they will stay clicked in until you remove the fault. This particular board derives its power from one of these high-link power supplies. You can see it outputs 12 volts and the input is anything from 100 to 240. So basically this module is fine for anywhere in the world, and the good thing is it's completely independent from your transformer and anything else in the circuit. Many of these boards that you can buy that run off a low voltage to start with, they don't like the same power supply or grounding as your amplifiers on, and you can get very odd, not nice results. Mains goes in here, the outputs from your amplifiers go here, the output from this board goes to your speakers. On the follow-up video to this particular subject, with the aid of help from Ron, who's very good at this, I'm going to show you a block diagram and the real world, how it looks when you've connected it. This one we've talked about what the ingredients use, but the follow-up video will show you how to connect it in close detail, as we've been asked to do this on a number of occasions. The final product, both Ron and myself are building an amplifier using the new modified L12s. Whether we will keep those remains to be seen once we've built the whole thing. We're building it in a modular form so that they can be swapped out as and when new things arrive. This is the back side, can I say back side? Yeah, I think I can, of the chassis that I'm using, and it is in fact an old Yamaha AV amplifier. The rest of the box contains a lot of space. There's going to be a preamp module up here, the two power amplifiers sit in here, and I'm going to show you how to wire all these things up with the aid of some drawings and schematics that Ron I haven't asked him yet, but I'm sure he'll be delighted to do those for us all. Sorry about that, Ron, if you're watching. I hope I haven't put you on a spot. Thank you for watching, everyone. Bye for now.